Hello everyone. This is a session of regression and CPS 15. I'm Manu Iwasaki from Yokohama State University, and I chair this session. We have 4 papers to read, and each speaker has 20 minutes for their presentation and discussion. The first notice is provided 10 minutes left and 55 minutes left, and they are finished. You have to go back to your seat. So our first speaker is Shimono Toshiyuki. On this title, please start the presentation, please.
I'm Toshiyuki Shimono. The title is Interpretable Multiple Regression, where an ellipse inscribed in a space in a square extensible to any finite dimensionality. The main content is as follows. The multiple regression can be interpreted using Euclidean ellipse or ellipsoid or hyperellipsoid. And these results may make it easy to understand the multiple regression, both numerical results and how to calculate, and also may help in solving machine multicollinearity and other difficult problems. I'd just like to explain the variables geometric shapes. X is explanatory variable, actually d-dimensional. Y is the response variable. And E and P play an important role in this presentation, and E is ellipse, and P is a point inside ellipse. And M is a matrix, correlation matrix upon X1 to XB. So it's D by D matrix. My slides consist of 4 parts. The first is background about multiple correlation. Linear combination model is widely used, as you know. And the many of basic statistical models and mathematical physics models utilize linear combination. And also pieces of machine learning, such as deep learning, also use linear combination. The output of multiple regression is regression coefficient, and multiple correlation coefficient, and partial correlation coefficient. I think they are basic knowledge. And this matrix representation play important role in my slide. I surveyed a lot of books, and about the partial correlation coefficient, I surveyed a lot of old and English books, but I just find only this Japanese book. Possibly one English book, such as written by Rao, may contain this formula, but I just couldn't find it. And the results by multiple correlation, as a background, is difficult to interpret in many ways. Multiple correlation coefficient sometimes can have large values unexpectedly, and the regression coefficient sometimes have different positive negative signs from practitioners' intuition, and sometimes it has very large values. The partial correlation coefficient has a similar problem. As other issues, multicollinearity and instability is also a difficult issue, even though multiple correlation is simple modeling. So I found from this part, I will explain my new theories. In my slide, ellipse, E, and P play an important role. And as a preparation, Ri is a Pearson's correlation coefficient between Xi and Y. Rij is correlation coefficient between Xi and Xj. So you can consider like this when dimensionality is 2. When dimensionality is 3, R3 will appear, and R1, 2, R2, 3, R3, 1 appears. Then I withdraw ellipse and point. S is a unit square with a dimension of t. So if t equal to this square, and with a coordinate of plus minus 1. So in this case, minus 1, 1, minus 1, minus 1, 1, minus 1, 1, 1. And determine ti with a coordinate like this. So in this case, t1 is a coordinate of r1, 1, r1, 2, that is equal to 1, r1, 2. t2, the coordinate of t2 is r2, 1, r2, 2. So that is equal to r1, 2, comma 1. Then draw an ellipse passing through these 4 points, t1, t2, minus t1, minus t2. If dimensionality is equal to 3, put t1, t2, t3, and also minus t1, minus t2, minus t3. And put ellipsoid inscribing this cube. Then put a point P with a coordinate of r1, r2 here. M is a matrix determined like this, and the ellipse is actually mathematically determined like a set of points which satisfy this formula. This is a preparation. Then my first theory. Multiple correlation coefficient is equal to the ratio of lengths OP over OP prime, where P prime is defined as the intersection of ellipse and the line OP. So multiple correlation coefficient is geometrically interpreted. This is a supplementary slide. So if m equal to 1, 0, 0, 1, this is circular, complete circular. If m is 0, 1, 0.35, 0.35, 1, yeah, this is like this. And if you put p, then you can read multiple correlation coefficient by reading this contour line. If m is equal to minus 0.81, minus 0.81, 1, the ellipse is like this, passing through these 4 points. And if you put p determined by r1, r2, that are the correlation coefficient between x1 and 1 and x2 and y, you can read